Algebra Superstars, time for day 2. We're going to try to make this go a little quicker than yesterday. Day 1, we had like 4 different topics that we covered. Today, we're just doing rules with exponents. And some of these are very easy, so it should go quick. Then we have some examples. So we'll get right into it. Zero exponent. Anytime you see a term or an expression or even just one individual item with an exponent of 0, it is always 1. So x to the 0 is 1. This whole expression here, negative 10m to the 12th, that is all in parentheses with an exponent of 0. So it all just turns into 1. The third one here, the only piece that has the exponent of 0 is the k. So that's the only piece that turns into the 1. 10 stays a 10. K to the 0 turns to a 1. And the plus 2 stays to a plus 2. This becomes 10 times 1 plus 2, which is 12. All right, so any piece that has an exponent of 0, any term having an exponent of 0 is just 1. When you add and subtract, exponents do not change. Exponents stay as is. They stay the same. They do not change. You can write in whatever works best for you to remember that the exponents stay the way they were. This is when we just combine like terms. Combine like terms. Like terms means same variable, same letter, and same exponent on that variable. So 3x5 plus 8x5, they are both x to the 5th. 3x to the 5th plus 8x to the 5th. We add the 3 plus the 8 and keep the exponent on the x the same. Second example, 10m to the 12th plus 18m to the 8th minus 3m to the 12th. You only combine the ones that have the same variable and same exponent. The other one that's different will not change. So this is basically 10 minus 3, because if I group the like terms next to each other by using the commutative property, which means I'm allowed to rearrange my items in my addition problem, I can put the 10m to the 12th minus 3m to the 12th, making 7m to the 12th first. And then I carry along and keep the 18m to the 8th the way it is. Now keep in mind, guys, you can pause this as you need and rewind it if you need to go over anything again. All right, third rule, multiplication. When we multiply the terms, we add the exponents. You're going to multiply the coefficients. Now, the coefficient is the big numbers. You multiply the numbers, but then you'll add the little exponents. So 3x to the 5th times 8x to the 5th. You do 3 times 8, 3 times 8, which is the 24. And then when we do x to the 5th times x to the 5th, you add the exponents to make it x to the 10th. So it's 24x to the 10th. All right. If there's a combination of multiplying and adding and subtracting, just follow the rules for each PEMDAS part of your problem. So the multiplication comes first. So you multiply the negative 10k to the 12th times the 8k to the 8th. So we will multiply the coefficients of negative 10 and 8, and then add the exponents on the k. So 12 plus 8 is 20. Once that part is taken care of, we can check to see if it is a like term or not a like term with the negative 3 to the 20th. Do they have the same variable? Yeah, both k's. Do they have the same exponent on that variable? Yeah, both 20s. So now you can go to your calculator and just do negative 80 minus 3. So that's negative 83. This is subtraction. Adding and subtracting keep the exponents the same. So we're going to keep the k to the 20th as a k to the 20th. Next one is multiplication, but you might recognize it as more of a distributive property problem. So we're going to multiply the coefficients, add the exponents. 3 times 2 is 6, and then on the exponents, exponent of 3 and an exponent of 2, add for a new exponent of 5. Next term, 3 times negative 12, we can go to the calculator, get negative 36. When we do not see an exponent written, like negative 12x, that means there's a little invisible 1 there. So when I multiply it times the x to the third, the exponent of 3 plus the exponent of 1 makes a new exponent of 4. Last term, 3x to the third times 9 makes it 27, x to the third. And that's our final answer. So I'll rewrite it up here on our answer line. 6 x to the fifth minus 36 x to the fourth plus 27 x to the third. There are no like terms here because each x has a different number for the exponents. So they stay all different, stay separated. Another distributive property. You know what? Let's do this. I want you to pause the video. Go ahead and distribute, try this on your own, and then hit play again, and we'll see if we come up with the right things, okay? So pause it, do it, then come back. All right, welcome back. So we multiply here and add the exponents. The number in front of the x to the third, when we don't see a coefficient there, it's a 1. So when I multiply, 2 times 1 is 2, add the exponent, making it 2x to the 8th. So if you paused it and tried it and got that, congratulations, fantastic. On to the next term. 2 times negative 5 is negative 10. Add the exponents. Exponent of 5 plus the exponent of 2 makes a new exponent of 7. Now here's something that we haven't seen yet. How do I multiply two different variables together? Because if it's addition, I can't add them together, but multiplication, we can. So you're going to multiply the coefficients just like normal. 2 times 7 is 14. And we're going to just keep both variables. Keep the x to the fifth the way it was, but we're also going to keep the m squared the way that it was. And we put them all together. One nice big term. Now, on to division. If addition is used for the exponents when we're multiplying, then it should make sense that subtraction will be used when we divide. So here we subtract the exponents. So it's always numerator exponent minus the denominator exponent. So it's top minus the bottom. Make sure you're subtracting in the right order when you're subtracting the exponents. So this becomes m 19 minus 7 is how we figure out the new exponent. So it becomes m to the 12th. So the theory behind this is that anything divided by itself is 1. 6 divided by 6 is 1. 8 divided by 8 is 1. X divided by x is 1. This m to the 19th is technically 19 m's on the top of our fractions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. On the bottom, we technically have 7 m's. 1, 2, 3, 4, 5, 6, 7. What happens is every time I divide an m by itself, that's just 1. So since this is all being multiplied together, when you multiply times 1, nothing changes. If I can take every m divided by itself and get rid of them, that means the 7 m's on the bottom would cancel out with 7 of the 19 m's that were on the top, leaving me with m to the 12th. So that's where the subtraction thing comes from. All right. So next, if we look at our next example, this time we have numbers involved. What we're going to do is go to the calculator and let the calculator deal with the coefficients for us. And then what I'm going to do is subtract the exponents on the variables. So I have 48 in the numerator, 64 in the denominator. I'm going to go over to my calculator and do 48 divided by 64 and hit enter. If you don't have one of these inspires, then you may get the decimal 0.75. If you get the decimal 0.75, you can use the math frac option to turn your decimal back into a fraction. And if you're not sure what that means, then you contact me by email. We set up a Zoom and I explain how to do the same stuff on a different calculator. All right? It won't take long, but I can show you how to do that. Calculator told me that I'm going to have a 3 left over in the numerator and a 4 left over in the denominator. So I'm going to put those in the right place and then go to my letters. With the variables, subtract the exponents. So for the A, I have 15 minus 7, which is a positive 8. Positive means it goes in the numerator. For the B's, I have 5 minus 8. I'll end up with a negative number. So I do B to the 5 minus 8 ends up B to the negative third. If the subtraction ends up negative, put it in the denominator of your fraction, but with a positive exponent. Always want to write your answer with a positive exponent. So the negative exponent here, after you subtract, is telling you, hey, this should go in the bottom of your fraction. Put it back in the denominator. Now the C's, we have an exponent of 7, an invisible exponent of 1, leaving me with positive 6. Put it in the numerator. And there we have our result. All right, so pause it, try the next one, and then come back. We'll see if you did it right. Or pause it and try the next two, and then come back and see if you did it right. All right? Great. So 18 divided by 6, go to the calculator. Maybe you just know that it divides out to be a perfect 3. And then subtract the exponents. 12 minus 8 is 4. So 3 into the 4th. And then 9 divided by 27 leaves us with 1/3. K1 minus K7 leaves us with K to the negative 6. So that tells us to put it in the denominator. Exponent of 2 on the H minus the exponent of 4 on the H, again is negative, tells us to put it in the denominator. All right, so there's most of the rules. A couple more. Next, power to a power. This means one exponent raised to another exponent. Now, I'm sure that you know that doing an exponent of 2 means to square it. So 4w cubed x to the 7th, that whole thing squared, means technically we would have 2 of those parentheses being multiplied times each other. But with these parentheses not having plus or minus signs in them, we don't have to distribute. We're just multiplying 4 times 4, w3 times w3, x to the 7th times x to the 7th. But we don't want to have to write that out every time, especially if it's like 3 of them, like the next example, or 4 of them, like one of the other examples. So what's the shortcut? Shortcut is to multiply the exponents. Multiply exponents when you have a power to a power. Now that only goes to the variables. Technically here, I would have 3 of the same parentheses. 3d to the 4th, e to the 5th, f, and then 3 of those. Negative 3, d to the 4th, e to the 5th, f, and another one. Negative 3, d to the 4th, e to the 5th, f. So I have to do negative 3 times negative 3 times another negative 3. You can use a calculator, or maybe you can do that in your head. But the shortcut here is to multiply the exponents. So d to the 4th, d to the 4th, d to the 4th would be doing the exponent of 4 times the exponent of 3, getting a new exponent of 12. And then e to the 5th times 3 makes it e to the 15th, and f to the 3rd. All right, so square the coefficients because our exponent is 2. And if you need to, you go over your calculator, and we have to do 18 squared. So you can either do 18 times 18 or 18 squared. And then multiply the exponents. and do that for the denominator as well. 6 squared is 36. Multiply the exponents. Now here, because I have n's on the top and the bottom and numbers in my fraction, I want to see if this simplifies and reduces some more. So I'm going to go to the calculator and do my 324 divided by 36. And the calculator is going to tell me, oh, yep, that divides perfectly into a 9. So this is going to simplify to 9. And then based on the rules that we just did, you're going to subtract the exponents. So 24 minus 16 gives me a new exponent of 8. Now it's simplified. You can simplify before you do the exponents if you want. So let's do that with the next one. Inside the parentheses, I have 108 divided by 36. So I'm going over to my calculator. I'm doing 108 divided by 36. And that divides out perfectly to be a 3. So then this turns into 3 in the numerator. Now I have r squared over r to the third. We subtract the exponents and get -1. Negative tells us it goes in the bottom. We just have a 1. And then the t is just the t to the 9th. So it's much less stuff to square now. Now I do 3 squared in the numerator, t to the 9th to the 2nd, multiply the exponents to make it 18. In the denominator, I square the r. So I simplified first and had less stuff to work with my exponent of 2. If the fraction inside the parentheses does not simplify, just do what we were doing before. So we do 2 to the 4th. That means 2 times 2 times 2 times 2. On your TI Inspire, there's a button that looks like, it's called the caret button. It'll make an exponent. It's next to the x squared button. You can see it in red on my screen. That's how I can make a number turn into an exponent. So that's 2 to the 4th. Okay, that's 16. And then I need 3 to the 4th, which is 81. So 2 to the 4th is 16. 3 to the 4th is 81. 2 to the 4th is 16. That's in my numerator. 3 to the 4th is 81 in the denominator. For my variables, k to the 6th to the 4th, I multiply the exponents, so it's k to the 24. H to the 9th to the 4th, I multiply exponents, so it's h to the 36. The letter k and the letter h are different variables, so those do not simplify, those do not reduce. All right, so pause it, try the last one here on this section, and then come back and we'll check it. Okay, I can reduce this ahead of time because I know that 24 divided by 6 will divide out to be an exact 4. And then W5 over W4, subtracting the exponents, it's a positive 1, so that goes in the numerator. And then I still have e to the 4th in the numerator. Now, all the denominator canceled out, so technically it's over 1. But if all the denominator canceled out, that means I don't need it. So I don't have to use a fraction. Just square the 4, square the w, and square the e to the 4th by multiplying the exponents. And there we go. All right. Last type of exponent we have to deal with is the negative exponent, which we already saw a couple examples of, but I want to show you what happens with these negative exponents if they're on their own and not part of a division problem or power to a power or something like that. A negative exponent means to take the reciprocal. All right, use the reciprocal. Let me redo my R, it's not a very nice looking R. Okay, so vocab word. Reciprocal means flip it. Switch the numerator and denominator. That's what we were technically doing over here with the division stuff. When the negative exponent was a result of subtracting the exponents in the original fraction, Notice I have b to the 5 minus 8 ended up with b to the negative third. As I wrote it there, I did not put it in a fraction, which technically means that this would be b to the negative 3 over 1, but then I switched it and put it in the denominator, almost like flipping it. That might not make any sense to you the way I just explained it, so let me show you what happens. On a calculator, we can do this with numbers. It does not work with variables, but it works with numbers. If we have negative 6 squared, oops, I want the negative 2 go over. I want the 2 with the exponent there. I want negative 6 squared where the exponent is on the outside. That means negative 6 times negative 6. But if I make this 2 a negative, negative 6 to the negative second, it gives me 1 over 36. I know that 6 times 6 is 36. So how did this end up as a fraction? Well, it ended up as a fraction because the numerator and the denominator flipped. So what happened here is this actually turned into, instead of negative 6 over 1 to the negative second, the negative exponent says flip it or switch the numerator and the denominator. That's what the negative exponent tells you to do. So once that action is carried out, the exponent that was a negative 2 will now turn into an exponent of regular positive 2. Squaring the 1 in the numerator, 1 times 1 is 1. Squaring the negative 6 in the denominator, negative 6 times negative 6 is positive 36. So the negative exponent technically takes your original value, which is usually just something over 1, and it's going to flip it, switching the numerator and the denominator. That's what the negative part of the exponent does. So once that action has taken place and you flipped it, you can turn the exponent into a positive number. 1 to the third, 1 times 1 times 1. 2 to the third, 2 times 2 times 2. And then k to the fourth to the third, remember we multiply exponents. So that's the final answer. So pause it, try the next two, or just try the next one and then come back. All right, welcome back. So we take the expression that's there, we flip it, and then we square it. So it becomes 1 over 36x to the 30th. Negative times a negative turns positive. That's why the negative 6 squared turns into positive 36. We can use the power to a power rule first to try to make this easier if you want. So I would have to distribute the exponent of negative 3 to each of the exponents inside. Now remember, this 2 has a hidden exponent of positive 1, so this becomes 2 to the negative 3, d to the negative 18th, and e to the positive 24th. Looking at it this way, I told you with the subtraction problems, anything that ended up with a negative exponent, put in the bottom. So this becomes 2 to the third in the bottom of our fraction, d to the 18th in the bottom of our fraction, but e to the 24th goes back in the numerator up in the top. I can take this one step further just because I know that 2 to the third means 2 times 2 times 2. That turns into 8. So there's a couple different ways you can approach it. You can flip the whole thing like I did the first couple examples, or use the power to a power rule, and then individually see which terms ended up with a negative exponent, and subsequently they will go written in the denominator. If your original problem was a fraction to start with, then you can just flip the whole thing. 5 over 3m to the third takes care of the negative part of the exponent. Now you just square the two parts and multiply the exponents for power to a power. So pause it, try the next example, then come back. So the first thing we're going to do is flip the whole thing. 3b to the third over 4a squared b to the ninth. Flipping that takes care of the negative part of the exponent. Now I'm just going to square everything. So 3 squared is 9. B to the third squared Multiply the exponents makes it b to the 6th. In the denominator, 4 squared is 16. A squared squared makes it a to the 4th. B to the 9th squared makes it b to the 18th. Now, I do have b's in the numerator and the denominator, and hopefully no b's in your house. Get so I'm going to subtract the exponents. So I will do 6 minus 18, leaving me with a negative 12 for the new exponent. Since that new exponent is a negative 12, b to the 6 minus 18 leaves me with a number that is a negative. That tells me it goes into the denominator. Okay, we are almost done. We are going to keep this under 30 minutes. So next, we're just going to multiply. All of the previous examples did not have plus or minus signs inside the parentheses. So these are called monomials. There's a lot of parts there, but it's all one term connected by multiplication. No adding or subtracting in any of the examples we did. As soon as we have a plus or minus sign in between our parts, we now have two terms here, not just one. In these previous examples, even though it's 2d to the 6, e to the negative 8, they're all being multiplied together. That's considered one term. This is x minus 9. That's two terms. X is one of them, 9 is the other. So you guys are all from different places. So I'm going to show you a couple different strategies that you may recognize of how to multiply the product of two binomials. So the first one we use in Penfield is the box method. So I'm going to take one of my parentheses, x minus 9, and the other one, x minus 2. And then I'm going to use multiplication, like a multiplication table. X times x is x squared. X times negative 9 is negative 9x. X times negative 2 is negative 2x. And negative 2 times negative 9 is a positive 18. Those four terms, x squared minus 2x minus 9x plus 18, can combine only in the middle, because I have two like terms here, negative 2x minus 9x. Those can combine just by order of operations. Negative 2 minus 9 is negative 11. And that is my final expression. So some of you may be fine with this and you're good to go because we're done for the day. Some of you want to see other examples or maybe a different method of how to do this. Watch and I'll show you. So one way that some teachers call this is multiplying this problem is FOIL. They say F-O-I-L. I'm going to use colors to help show you what the FOIL stands for. The F is the first term in each parentheses. So that means x times x. The O is the outer term. That means the very first in the front to the left, all the way to the back and the right. X times negative 3, negative 3x. So first term in each parentheses, outside terms. Then the inner terms, the two closest to each other, one from each parentheses, 7 times x. And then the L is last, first, outer, inner, last. But just like our previous example, we can combine the two terms in the middle. They are like terms. Now, we will not always get 3 parts to our answer, okay, depending on the questions. So I'll show you an example. But again, if you feel like you know what you're doing now, you can stop and then go find some practice problems to do. Or you can just keep watching and we'll have more fun together. This is an example, I'm going to use the box method, of when there will only be 2 parts to your final answer instead of 3. Y minus 5, y plus 5. When I start filling out my table using multiplication, because it's the same number, 5 and 5, but one's plus and one's minus, when I do the multiplication and then try to combine like terms, the middle 2 terms cancel out and end up as 0 and disappear. Okay, so that is under 30 minutes. You have a couple practice problems if you want. X minus 9 squared. You would write x minus 9, x minus 9, and do it out that way. All right, guys, good job day 2. We'll see you later. Day 3 coming soon.